Hey everyone, today we are solving developer from HackTheBox, a hard-rated Linux machine. We can see here in our Rust account we have port 22 for SSH and 80 for HTTP open. Go ahead and run some web enumeration stuff, so go buster, hit enter, go ahead and run what web just to see what we're dealing with. We're getting some data back, I'm not entirely sure what to make of this so far. And we can see we're running Apache and we have some kind of CTF platform going on. Let's go ahead and look at the application more directly. I'm going to go ahead to the web app. And we can see here it's some kind of CTF website. So whenever I do my testing, I tend to take a exploratory approach and basically just click as much as I can just to see what happens, and while my burp suite goes ahead and populates everything I click. Go ahead and re-enable this. Should be there. My bad. Probably need to enable my proxy. Indeed I do. There we go. That should now work. I'm going to go ahead and basically click stuff and just basically let burp fill in the gaps. There we go. Cool. Sweet. Alright, so I'm going to go ahead and basically just click some stuff and see where it goes. Sign up, already been there, about, features. I mean, burp will do all the stuff for you when it does its passive scanning, but for the sake of just making sure that it obviously follows all the pathing, that's how I like to do it. Okay, so since I can't see anything immediately here, I'm going to go ahead and check out my dirbuster. You can see here we have just a bunch of stuff really. So my approach now that I've kind of seen what's going on there is I can see here that we have a lot of very similar response lengths, which kind of tells me that this is almost a dead end and we're not really getting anything back from there. It's not an actual page, it's just a page responding with 200 and that is that. Okay, let's go ahead and create an account. Sign up now. Go ahead and I should have some kind of history in here. I'll go ahead and just use Sakura and then whatever password I used before. Yep, cool. If it wants to let me sign up, that'd be great. There we go, sign up. So now we're signed up, cool. Now we have access to, obviously, the dashboard. We previously did not have access to that. And we can go ahead and click stuff. Again, just want to basically enumerate what's on the page. And really just see, you know, what we can click, what we can do, what functionality we have. We can see here there's a few buttons. We can submit a flag, some kind of user input here. Interesting. And we really want to basically locate all the relevant content and all the relevant input and just really see what we can do. So when I first did this machine, I looked into the changing password and the change email function. I thought maybe there's some SQL injection stuff going on here, you know, like setting primary, but that didn't seem to be the vector. So I moved on. What caught my eye later on though was the use of these CTF challenges. So one thing I overlooked when I was doing the testing is actually looking at the web app for what it was in terms of an actual CTF site with actual CTF style challenges. I thought maybe the vulnerability would be, say, in the profile settings, but it wasn't. Okay, so I'll go ahead and check out, say, one of these. I personally did this one just because it just seemed quite simple at start. We'll go ahead and download, say, here. Go click, go to save. Cool. Go ahead and pull it out there. Cool. We'll go ahead and unzip it. Cool. We should now have an Excel file. Cool. And the way that Excel files tend to be put together on most Microsoft products for the Office range is they are actually zip files. If we go ahead and bin walk it, you'll see here, if we look into Phish credentials, Phish credentials, you will see actually that it actually appears to be basically a bunch of zip files. This isn't steganography, this isn't forensics, this is just how Excel files are put together. We go ahead and extract it using bin walk-e. Then we go ahead and view inside our code. We can see here we have the file. When I did this box originally, I went ahead and basically just looked at all the individual content. You can use, say, grep and stuff, but in my case, I literally just had a quick look at, you know, what was in there. And I saw when I went to the bottom of here that we have what looks like a flag. I went ahead and pulled this out. I'll go ahead and just put this into a mousepad. Just for safe keeping. Cool. Go ahead and now pop this in here. Now, one thing I didn't realize when I did this is by doing this, I would get additional functionality. Now, when I submit this, you'll see here it says submit flag. And then now I've submitted it and I go ahead and refresh the page. You now see that it says completed and now I have a submit a walkthrough. So by completing the CTF, I've actually bought myself an additional bit of functionality I wouldn't otherwise have access to. So that was interesting. So how does this work? So if we go ahead and read this, it says your walkthroughs will be on your profile page and public profile page. Admins will check the walkthrough as soon as they can and reserve the right to delete them where necessary, and then enter the URL here. Now, when I first did this, I was like, okay, well, is it going to make a request to our web page? You know, is it going to pull it down? in the end, I realized this is more of a client-side attack. So what came to me was the use of tab nabbing. Now, if I go ahead and open up my previous tab, you'll see here I have a HackerOne report, and before that I have a HackTricks page. Now, the way that tab nabbing works, or reverse tab nabbing, is basically when you click a link, say I go to, say, like somewhere on here, right? Like I'm clicking here and it takes me somewhere. What happens is the legitimate page will make a request to, say, my web server, or like, say, this URL. And this URL will then have a bit of JavaScript in there, which controls my original page. So when I click, say, about the author, this opens up here. But actually, this page has got control over this page, if that makes sense. So if I can effectively make the other page do something, then what I can do is I can then inject something into the page. So what that means basically is that the legitimate page will call out to, say, about the author. And then when this page then renders, it will then add in this little bit of code here saying opener.location. And then it will then actually control the location of this page. So by effect, what it's doing is a legitimate page calls up to us. We then control the origin page and then modify where it goes. So the way I want to exploit this is effectively we're going to have a few things going on. So I'm going to go ahead and have paint here. So this is our victim machine. So we'll put a V here. What happens is the admin will then make a request to our URL. Our URL will then modify the origin of this page and make it go to our other page, if that makes sense. So here we'll have like a HTML page. And then here we'll have a page which will basically just have the form in there. And the way this will work basically is we want to go ahead and mimic the login form. So the admin will then basically go to our URL, or follow here. This will then get modified on this end, and then it will then be given a new form. They will then submit the form, and then the data of that form will then go to our other listener. It will make more sense when I demonstrate it. So what we want to go ahead and do is we want to go ahead and create a very basic page and have some HTML in there. We'll go ahead into here. We have a fish directory I created real quick. I'm going to go ahead and get a new file, and we'll just call it fish.html. And what that's going to include is basically just this bit of code here, like so. Go ahead and just paste it in here. And then we want to go ahead and then change this to be us. So in our case, we want to go ahead and make it, say, I'll do like lweb, and that will give basically a link to where I am right now. Go ahead and take this. That will do. So what this will do is it will then redirect the admin to a page we decide. In this case, I want this to be called, we'll just call it, I don't know, pwn.html, and you'll see in a minute what I'm going to do. So I want to go ahead and basically make a page which will look like the login page. So I'm going to go ahead and do is I'm going to go ahead and then steal the login page. Let's go ahead over to here, go to close, go over to logout, go over to sign out. And then here with the login page, just go ahead and click save page as. Go ahead and save this as pwn.html in the fish directory. Now when we go ahead and view it, so I'll go ahead and now view pwn.html. Go to opening content folder, go ahead and double click this, and boom, the page is the same. Now you can actually see here, this is actually a local file, but yet it looks like our remote page. If I go ahead and now modify just a few little details. So right now we have account/login. I actually want this to be to our own host. I'm going to go ahead and grab this. I'm going to go ahead and modify this to be an absolute path to our host. I'm going to go ahead and make this a 1 and go ahead and just so we can leave it like that. That'll be okay. And then now if we go ahead and open up a netcat listener. So go ahead and do netcat-nlvp 9001, like so. And then we now go ahead and refresh this page, and now we go ahead and type in Sakura, and then be like, sub, please. We'll go ahead and now see that data is actually being sent to our netcat listener. And what that means basically is going to have a way to basically capture the data. So the way that this is going to work, we'll go ahead and open up Paint again. Go ahead and create a new one. So we have our victim. Wrong one. We have our victim. They then click our link, which then takes them to fish, which then modifies their origin, which then takes them to pwn, which then sends their data to our port 9001. Hopefully that makes sense. Okay, so based off that, what we want to go ahead and do now is just go ahead and check that it kind of all works. So if we go ahead and We go ahead and listen on here. So just to recap, I have a netcat listener on port 9001, waiting to receive input from our web admin. Submit a walkthrough, go to submit walkthrough again. Go ahead and just clear this. Cool, a request is made, and boom, we have the admin and we have the admin's password. Sweet. Go ahead and take this, copy it to here, go ahead and pop it into burp just to clear it, just to clean it up because it had some stuff in there. Cool. And there we go, we have the admin username and password. Cool, go ahead on to the next stage. Pop this into here, go ahead and just, cool. All right, so now we have the username and password. Let's go ahead and drop it in here. Let's go ahead and log into here. Now, one thing you will notice if you looked at our web enumeration is that there is an admin located somewhere in here. Admin here, I believe, admin there. So basically it's a little bit hidden, but there is an admin in there. It's always worth checking. So if I go ahead and change this to admin, we'll go ahead and see there's actually an admin prompt. Go ahead and log in as admin. Cool, go ahead and log in with the password we got. So now we have a Django administration page. Interesting. So now we're a little bit further. Let's go ahead and just basically go ahead and see what's on the page. So we have email addresses. Interestingly, so we have our account, we have Clubby's account, we have Will Wham, DM Wong, Jazz Pizzazz, and Clubby. Nothing interesting here. That's all we can really see. Just a few email addresses, no worries. Look at users. Okay, here we have admin. We have admin at developer.ctf. We have Jacob and Taylor. Okay, so we have a first and second name. So in future, if we come across with Jacob or J Taylor or something like that, it's probably the admin and then nothing else that's interesting. Okay, we have challenges solved. This looks to me like it's basically a database, which is interesting, of course, because we actually want to go ahead and maybe get access to this later on. Next, we'll go ahead and take a look at sites. Now, interestingly, with sites, we actually have the developer.sentry. So I've already added this to my Etsy host, as I mentioned, I've done this box before. So go ahead and cat Etsy hosts. If I can type properly. Cat Etsy hosts. You can see here we have developer sentry developer.http. So now if we go to this URL, we should then be directed to the right place. Okay, my apologies, I'm logged in already, that's fine. I'll go ahead and just log out for the sake of consistency. In this case, interesting actually, I have reset the box since, so this box shouldn't be alive, but it is. I solved this box a little while ago, so yeah, anyways. So we don't have access to this. I know I have admin here, but we shouldn't have access to this, so we'd go ahead and basically create an account. If I go ahead and try this, it won't work because it doesn't exist, so we'd go ahead and register. So now we're registered, and we can see here there's a Sentry 8.0. Now my research of looking into Sentry 8.0 basically led me to find a PDF I will show you in a second, which referred to here, pull it down, talks about basically a vulnerability in Sentry pickle. So reading this basically, although the version numbers don't quite fully match up, obviously we're using version 8.0, this site is actually vulnerable to it. Again, it's always worth checking, even if numbers are quite similar but not exact. What it means basically is that it's vulnerable to a pickle deserialization bug within the Sentry application. So we are given a few little bits of information here as to whereabouts it's vulnerable. So we have HTTP Sentry, host admin Sentry, or audit log Sentry. I'm going to go ahead and grab this and go ahead and append it to our current URL. And it says here it wants us to log in. Now, how can we log in? Well, we need to go ahead and basically figure that one out. Using our previous knowledge of the page, we can go ahead and actually look at, what users and stuff there are. I'm going to go ahead and just duplicate this and go back one. And here we have a number of buttons. And if we go over to members, we can see that we have a Jacob Taylor. And if you recall previously, we have a Jacob Taylor here, which is admin, and we logged in with the admin credentials. So it's possible to make the jump that Jacob is an account. So we'll go ahead and log in with Jacob. And then his password of the same as the admin password, which is this one here, super secure password. Go ahead and hit login. And that should work. Cool. So now we're logged in. Sweet. And now we can see we have audit log Sentry. Now the way that this works basically is it's sending a post request to the page. As you can see here, simply all they're doing is they're just adding in some data here, and that data will be our serialized object. So what we want to go ahead and do is just basically click any of these here on the page. Say this top one. We want to go ahead and replace this with a serialized string. Now, luckily, the page has given us some of the actual code to work with. For the sake of ease, I'm going to go ahead and just copy my previous one. Just due to formatting, it's going to be a little bit easier. And go ahead and just remove some of the bits that don't need to be there, as it's a little bit of a spoiler. I think it should be called Intercepting. Yeah, cool. I'll go ahead and grab this. So just pop this in here. Should now have it in our directory here. So Intercepting. This one here. Go ahead and just remove this so we don't spoil it too much. Okay, cool. So let's go ahead and now pull out the bit we want, the bit that we're missing. So the way that this works basically is paste this in here. Cool. What we're doing basically is we are creating a serialized Python object, and then when we actually when this is passed through the reduce, it will then actually return the opening of the argument we provide. Basically, what that means is when it's passed via the reduce method within the pickle object, what it will actually do is it will actually then execute whatever code you want. In this case, netcat or whatever. So we can go ahead and say, do you like a curl? So curl 10 10 14 9 on port 9000 and hit save. Cool. Go ahead and now go to terminal, go to new terminal, and we're going to go ahead and run this. I think it's Python 2. Go ahead and just go into the right directory. Intercepting. Cool. So now we have this. I'm going to go ahead and just hit copy on this. Go ahead over to my thing here. Go ahead and just replace this with that data. Go to burp suite. Go to proxy intercept. Turn that on. Go ahead and hit save. And now it should catch it in burp. Go ahead over to here. This is how it should be, but we're basically just going to replace the data here. I know this is already my data, but obviously just make sure it's definitely done it. Go ahead and hit send. Okay, nothing obvious on that end. Go ahead and now check on our page. So we don't have anything here right now, so I'm going to go ahead and just clear this, just clean up a little bit. I'm going to set up a web listener. Let's go ahead and have another go. Hit send. Looks like we had a request made from 1 of 3. So we actually have command execution. I know that because if I go ahead and change in here in Secdisa to be, say, Sakura, go ahead and then rerun it, go ahead and grab it, copy, go ahead and pop it into burp again, hit send, we'll then have a request saying Sakura. Basically what it means is we can kill stuff, which is cool. Now I spent a little while basically doing something very simple of just basically killing a reverse shell and then passing it to bash. That attempt didn't work. What I found to work well, due to basically special characters, is the following. I'll go ahead and just minimize this. So I tend to do a lot of my exploitation locally, just so I can know that it will probably work if it gets executed by bash or whatever. So I'll go ahead and just get these out of the way so we can see. Okay, cool. So I'll go ahead and have 2 terminals. So this will basically be our listener. So NLVP1337. Cool. So what I want to do basically is get complicated characters. For example, you know, like this in our payload, and that can often trip up, you know, Python code, anything in between. It's quite difficult. Whereas if we can minimize the character variation, you know, as into A to Z and 1 to 9 and maybe the odd special character, it's going to definitely trip up the things a lot less versus having seen forward slashes, semicolons, angle brackets, and signs, pipes, all that jazz. Something, it might trip it up in the long run. So my approach to bypass this was use base64. So what we can do is we can use base64 to get around any character issues it has. By minimizing the amount of characters we use, we minimize the likeliness that they're going to trip up the program. So what we can do here is we can say like echo who am I to base64, like so, and it will give us that. We can then use base64-d to then decode it, using the pipe sign to basically pass this data into this and then pass the output of that into this. When we get the data back, then we can then pass it into bash like so, and then it actually will process it. If we go ahead and say change this to groups, it will then give us our current groups. we go ahead and remove one of these, we get groups, we go ahead and remove the decoder, we get the base64. So basically what it's doing is we are converting our ASCII plaintext into another format, decoding it, and then passing it into bash. Now, why would we want to do that? Well, certain things don't like complicated. Certain applications will just die if you throw a bunch of, such characters at them, like single ticks, semicolons, brackets, angle brackets, anything really. Things can break very easily. So this way we can get around it really. What we can do that way is so we can take this big payload and apply the same logic to here. So we can go and say ahead and say open up here shells 1338. We'll go ahead and now replace our what we had before, this echo groups. We'll go ahead and just change this to be echo our reverse shell. Hit enter, and we got a connection refused. Not sure. Oh, I know why. It's because our IP was not the right. The port was not the same. That's fine. Go ahead and update the port, and boom, we have a connection on ourselves. So we're taking this data, converting it to base64, and then decoding it. But we can't do this as a final payload, so we need to go ahead and do some of the work ahead of time. We'll go ahead and open up the listener. We'll go ahead and actually just trim the bit off here, like so. We then want to go ahead and just copy this. I'm going to go ahead and actually just add in -W0 to make it one line. Cool. And then go ahead and now I'll go ahead and now change the echo part here. So now we're actually just going to remove all this crap. Like so. Hit enter. Cool. That's fine. And then we'll go ahead and then pass it into base64 decoder, and we get their input back. Pass that into bash, and then we get our reverse shell. So you'll see down here, connection to our reverse shell. Sweet. So let's go ahead and now try that inside the actual application. But we need to go ahead and just do one thing first, because basically application, the D0's payload isn't going to know what to do immediately with this command, because although yes it is in a command format, it doesn't know to use bash. So we need to go ahead and wrap this with like this bash -c echo, and then basically that will then work. Go ahead and now do shells again, hit enter, and we have a reverse shell. Sweet, cool. Let's go ahead and now take this, go ahead and pass it into our insecure deserialization code here. Like so. Hit save. Remake it. Copy. Make sure the listener is here. Like so. Go ahead and then pop it into burp. Hit enter, and boom, we have a reverse shell on the system, and we are away as a developer. Sweet. So now we have access to the underlying system. What we'll go ahead and do now is we'll go ahead and just do our standard Linux privilege escalation techniques. So I'm going to go ahead and implement a new terminal here. Go to cd, to my root directory tooling, go to armory, go to Linux, go to privesc, and then we're in there, cool. lweb, and then we should have these files. Go ahead and grab these, like so. Copy, go ahead and cd into temp, go ahead and hit paste, cool. These are now running. I'm going to go ahead and just check that they're in here. Cool, they're now in there. Sweet. What I'm going to go ahead and do now is I'm now going to go ahead and do bash limpies, like so. I'm going to go ahead and then pass it into, just going to go ahead and pipe it out to linout.txt. But I'm then going to background it as well, so I don't have to watch it do it. Wrong character. Cool. And then that will now do its own thing in the background. You'll now see that if we now cat limpies linout.txt, you'll see there's some data in there. This is going to fill up basically while we're doing our own enumeration. And I don't really fancy looking at it, so I'm not going to. Okay, so what I want to look at now basically is interesting directory. So I believe we spawned in var. I'm not sure where we spawned. My apologies. I'm going to go ahead and just open up a new reverse shell. Actually, there's no need. I can actually just scroll up and see what directory I spawned in. That would make more sense. I wanted to see what directory I was in originally, I'm not sure. I didn't actually get a chance to check. That's okay. I'll go ahead and actually just go from where I am. So regardless of where I spawned, what I want to go and do is look at interesting directories. I'll go ahead and check out var. Okay, go ahead and check out www, because obviously there's a web server running. Well, here we have a developer CTF. Okay, cool, fine. Go ahead and CD into developer CTF. Cool, go ahead and hit ls, and we can see there's a bunch of stuff in here. Go to ls-la, and we can see here we have a few directories and that kind of thing. One thing that caught my eye, of course, is, the fact that there's Python stuff in here. Go ahead and check out, say, this directory, as it seems interesting. Go ahead and hit ls, and we can see there's a settings file. Interesting. Go ahead and cat it. And it looks like there's some values set in here. That's okay. We'll go ahead and keep scrolling up and just see what we can find. And we can see here there's a database configuration. I'm going to go ahead and copy this and save it to my mouse pad. So here we have databases, Engine, Django, PostgreSQL for the platform database, for the CTF admin, and this is the password. Okay, awesome. Let's go ahead and now use this. Go ahead and minimize this, so paste. And then I think it's -d for platform. Cool. Go ahead and now take the password of CTF Go 2021, enter, and we should be in. Cool. We can now go ahead and do a question mark perhaps, if it wants to work. D-L. Okay, yeah, it's working. Yeah, cool. So -L will basically give us a databases. We are connected into platform, so we're just going to stick with that. If we want to connect into another database, we just use \3 and say platform, and then we would then connect to the new database. We only have access to platform though, as you saw in the credentials, it just says platform. And I tried Sentry. We can actually connect to Sentry, but we can't actually read anything. We'll cover that later. Okay, so where do we go from here? So I actually want to go ahead and look at basically what tables. So I think it's -D to show me the tables. It is indeed. Let me go ahead and see here that we have a dozen or so tables. One thing that caught my eye is auth user, so I want to go ahead and basically select all from auth user, semicolon, hit enter. Not sure what I messed up there. Oh, I spelled select wrong, my bad. Hit enter, cool. And now we have a bunch of stuff in here. I tried to crack these hashes, but they weren't that helpful. Okay, so where do we go from here? Well, turns out this is a bit of a dead end. You can't actually do anything with this. So I was curious how to get into the next directory, the next database. So if I do like -L, you can see here there's a Sentry database. If I go ahead and do \backslash Sentry and go ahead and do the same command, select all from auth user, we say we get permission denied. Okay, interesting. So let's go ahead and actually, I think it's exit is what we're looking for. Okay, no worries anyway, I'll just go ahead and kill that, it's fine. We go ahead and just open up a new reverse shell. We should now have a shell, cool. Go ahead and just close out of the way. So I want to go ahead and look for Sentry as a file, right? So I go ahead and use this command here. Find basically all files in the root with the name Sentry, and exec grep on it, look for the word password, and then pipe any errors out to devnull. Hit enter, and we should get some data back. For some reason it's taking a second, but if I just scroll up, you can see that we actually got data back. This came back instantly, whereas this version did not. For some reason, I guess the box is dying on me. That's okay. What I'm looking for is basically some kind of thing here. So here we have a password of Sentry password 2021. But as helpful as this is, I actually want to know where it came from. Annoyingly, find didn't tell me anything, which is unfortunate, but that's okay. I can go ahead and basically now grep for this exact string, just basically in the in here. So go ahead and hit this, and we can see here it's in the Sentry conf file. All I did here is just grep for the password on some of the root directories and just found it straight away. It's quite straightforward. That's not what I wanted. I wanted this. Let me go ahead and now just cat it. Remove the colon. Things are being a little bit slow for some reason. I don't know why this isn't working. I went ahead and then just reconnected my shell. Catting it has now worked. So I just basically killed my shell and remade a new one. If we scroll up here, we can see here we have another DB bit, very much similar to what we had before. Databases. Grab this, copy, bung it into here. And now we have a Sentry DB with Sentry password and Sentry username and password of this. We'll go ahead and now adjust our original query to be like this. go ahead and basically we'll use, I think it was PSQL, like this, yep, cool. Go ahead and change the username to be Sentry, and the database to be also Sentry, and then it will prompt us for the password when we log in, like so. Hit save, and now we should be good. If I do \L, we're now in, cool. We go to select all from, actually I need to look at what's in here so far, so -D. We can go into here, pull out the auth user, select all from auth user, semicolon, hit enter, and we have some hashes. We'll go ahead and grab this, it's hard to read. Go ahead and get a new file, call it hash. We'll go ahead and save it in the upper level directory hash. Cool, go ahead and drop it in here, and we'll go ahead and just basically check how this writes. So we don't care massively for Sakura since that's our own account, but we do care about, say, Jacob or Karl. So I'm going to go ahead and just basically remove this top one. I'll go ahead and extract this out here. Go ahead and just put this in here. I want to focus on just the one hash for the moment. Cool, go ahead and hit save here. We'll go ahead and now investigate how to crack it. So I want to go ahead and grab everything up to here, like so. I'm going to go ahead and open up this here, just something a bit less cluttered. Go ahead and remove this out of the way, minimize. Go ahead and do hashcat -- examples, I think it's called. Example. Yep, cool. Go ahead and then grep for the string we're looking for, so this one, and it tells us to use this hash. Now, we don't actually know what ID to use. Funny enough, actually, it's kind of here, but for sake of knowing for sure, we add in -B5. It will then tell us it's mode 10,000, so we want to go ahead and do like this. I just basically moved into the directory, into the developer directory, and then we go into --show, and then we are given the password of insane clown posse. Cool. Let's go ahead and now SSH as Karl at $box, because that's my variable. Go ahead and drop this in here, and we should be good to log in. And yes, we are. Hit sudo -L, and we have the next stage. Drop the password in there. Boom, root authenticator. And then here comes a binary analysis. Cool. Go ahead and just cat the user. .txt, and boom. Cool. So what we're going to go ahead and do is we're going to go ahead and download the root binary. So if we go ahead and do sudo -L, go ahead and just put the password in here, we'll see we have this root binary. Let's go ahead and now go to SCP. How many times that? SCP. Karl at $box, then the path to the file, like so, and then just stick it in here. We'll call it root auth. Cool. And then we want to set our password, so we'll go ahead and pull it out. It's saved here. Cool. Go ahead and hit save. Okay, cool. So that's good. Now go ahead and download it. Now, while this runs, I went ahead and have my Ghidra ready. So because we're doing binary analysis, we need to go ahead and, of course, do some actual analysis using the proper tooling. I have Ghidra in this case, as it's just, pretty solid tool. It doesn't have dynamic analysis, which is a shame. However, we can match that up with GDB, and we should be okay. It's not the most intuitive way, but I use other tools like Cutter, but they just didn't quite cut to the bacon, so to say. Anyways, we'll go ahead and use Ghidra. So I'm just going to go ahead and I'm in Ghidra here. Get it working. Cool. So Ghidra's going to go ahead and load up. We'll go ahead and open up our root auth. I want to go ahead and open a new one though, just because I want to make sure we're not getting any of my previous work that's going to be in there. We'll go ahead and just come back a directory. So we're using up one, go to our actual video directory, go to wherever it is, developer, cool, go to, yeah, we'll stick it in here, but that will be fine, cool, and we'll just call it root auth 2, cool, so there's no mistakes, cool, go to that should be fine, we'll click this, press that. Ghidra will then open up a fresh project, however the binary isn't in there yet. We'll go ahead and import the binary is in, just check we're in the right directory. Binary will be in here, so developer, the normal one, root auth 2, not that one, root auth this one. Cool. We'll go ahead and hit OK. Go ahead, and when it loads up, we'll go ahead and tell it we want everything, so we'll go ahead and analyze it. Select all, analyze, cool. Give that a second to run through. Now, the way this is going to work basically is we need to go ahead and figure out how the application is working. Now, with most binaries, we're going to go ahead and look at like the main function. That will be our first port of call as to how the application works and that kind of thing. So just give it a second to finish before we start clicking stuff. But we do have here a symbol tree. Now, in a normal binary, we can often just find the main function in the exports. However, the main function in this case isn't really the main function, as I later found out I spent a while messing with. There's not a whole lot going on in the main function, it just does some stuff and that is pretty much it. So, an easy way to get to the next step is to either go to search and then search for the word cyber, because we know that when we run a tool here, actually I'm jumping the gun here. Let's go ahead and just run the tool. My bad. Root auth. What happens basically is when we run this, we have a welcome to CyberGeek Super Secure login portal. Enter your password. We put in the password here, and then it will tell us we're using the wrong password. We want to look for the word cyber basically, because obviously it's before. So I'm going to go ahead and look for the word cyber. Go ahead and all fields. Go to search all. We might get a return. It's currently loading, so it's a little bit slow. That's okay. Here we have, say here, so we have welcome to the CyberGeek so-and-so. Here it should be here. So we can see here, we have welcome to CyberGeek Super Secure whatever. For some reason, our decompiler isn't actually pulling this in line with where we are. So just so I make sure it does, I'm going to go ahead and go into namespaces, go to A, go to authentication, go into main. And then now it should then load up the proper what we're after. And then you'll see here, welcome to CyberGeek Super, whatever. Okay, so the way the decompilation has worked isn't quite perfect. It's not that easy to read. So what I'm going to have to do is I'm going to have to basically just guess what's going on. So we can see here that it's looking for a password. And if we scroll down a little bit more, we can see here that we have the use of AES. So that kind of tells me, and again, when I did this, it took me a lot longer. That basically tells me that we're using AES encryption. So the actual password won't be stored in plain text in the binary. So there's going to be some complications in there. So what I'm going to go ahead and do is I'm going to go ahead and just copy this, like so. Go into my Firefox, drop it into here. It's not what I wanted. I wanted this. Copy. Go ahead and have another go. And we'll see the first result is this Rust documentation. Within the Rust documentation, it basically tells us there's 3 parameters. The key size, oh, didn't mean to click that. The key size, the key, and the IV. Okay, so in our case, if we look over to Ghidra, although it's quite hard to read, we have what looks like to be the key and the key size. Or the key size and then the key. Sorry, let me restart here. We have the key and the IV. There we go, that's what I'm trying to say. All right, we have the key and the IV, most likely based on obviously the commas here that split up. These bits here are the length, by the way. So if I highlight over this, Ghidra will tell me that it's a length of 16, and this will tell me it's also a length of 16. We'll also see down here we're looking for a length of 32. So that's how we know basically what these hex numbers represent. So this is the key, and this is the IV. One thing we can do to make life a little bit easier is I think if I can go to right-click here and go to rename variable to be, say, key. And then I'm going to put 1337 at the end just so I know that I set it as that. Okay, cool. And we'll see here that we have, when I go to key, we have key up here. Interesting, okay? So this key is there, and then this key is referenced down here as well. We'll go over to rename variable. We'll call this one IV. And I'm going to put an underscore so I can actually read this as 1337. And then that with that, and then we can go ahead and middle click this here, and then we can see here it's represented here. Okay. So what we want to go ahead and look at now is the actual data that's going in. Now, this key here should be of length, I think 16 it said? Yeah, 16. Now, if we go ahead and middle click this, we can see the key is here. Now, the length of this isn't 16. I'm not sure if it says it, but it isn't 16. I think the W char means wide char. I'm not sure. But this basically isn't 16 long. So I believe we can right click this and go to retype variable. And basically go ahead and make it so it's actually a char of 16 length. So much like how we have up here, we have a W char 16. Is it here? Nope. Highlight this. We have a W char 16. We can just basically replace the W. Go ahead and go over here, right click, go to retype variable and type in char. And then open an array length of 16. We'll go ahead and hit enter. And then now we'll see that these have all been renamed to be the full length. Basically what this means is we have this key 1337 is actually split up into 4 bits, 4 segments really. So these all equal up to 16. Okay, cool. We'll go ahead and do the same here. Now, this took me a while to figure out in the first place. I was thinking that this one line was the key, and I was like, that's not 16 length. But after Googling a bit, I realized it's because basically Ghidra has messed up, and this is a solution to basically convert it from a wide char, or whatever wchar is, to a char of 16, and then it will then go ahead and give us a full length wherever we were. So now we have the key, and we have the IV. Okay, cool. So I'm happy with that. So we have a few bits here. We have the key, which goes into here, and we have the IV, which goes into here. Again, to see how I middle click this and it shows all 4. Okay, so where do we go from here? Well, we want to go ahead and look into more how this code works. We can see here, if we scroll down a little bit, that we have a comparison, okay? So we don't really know what this lstack 552 is, but we do know that it's checking if it is equal to the length of 20. Now, this could maybe referring directly to the length of our input data, but we can't really tell that right now. It's not really that obvious, and I'm not amazing at binary analysis either, so it's probably an error on my end. So the next step is basically use GDB. Now, I'm no expert in GDB. I've done bits and pieces, but I'm really no expert, so just really apologize if I don't do this quite perfectly. When I did this, it took me quite a bit of help, asked people questions and stuff, and yeah. So we'll go ahead and open GDB. Certainly area I want to improve on, but that's okay. We all got to start somewhere. We'll go ahead and run root auth. Okay, cool. So what we want to go ahead and do now is we want to go ahead and set a breakpoint. Now, again, another thing that I found issues with is GDB doesn't quite match up with these addresses. If we go ahead and start from the beginning, so we go over to here, we go ahead and do break main, go ahead and just make Ghidra small, minimize, and go ahead break main, and then we'll go ahead and run it. We'll see that we actually break at here. Now, if we look at the address, we have all these 5s. If we look into Ghidra, we don't have 5s. There's none of this going on there. So after, admittedly, this part really stumped me. I didn't know how to debug properly Ghidra to GDB, but I've realized afterwards, basically, what we're looking for is the last three bits of here. So last 3 bytes. What we want to now do is basically remove the last 3 bytes off of here. And so basically these, and replace them with the ones in Ghidra. So let's figure out where we want to be. So where do things relate to? So where I'm interested in is, say, this one. But what I'm more curious about, obviously, is like what happens if we want to try and get to this line, basically. So if we can fulfill this, we can then, of course, get to here. Okay, we'll go ahead and click here, and we can see that it is 9B9. Okay, so I want to go ahead and just keep that in mind. We'll go ahead and then I'm just going to go ahead and just again, no expert in GDB. So the way I found it easiest to not break things is basically just quit it and then just reboot GDB, because it seemed to like glitch if I did it a different way. So I'm going to go ahead and break on star, which points to that memory address directly, and then we're going to go ahead and just remove the last 3 digits. So 1, 2, 3. Go ahead into Ghidra. Go ahead and take the 9BD, minimize. 9BD, hit enter, go ahead and hit run, and then it's asking us for a password. Let's go ahead and put in a bunch of characters. We got a wrong password. Interesting. Where are we now then? So in order for us to get to here though, we didn't quite hit the breakpoint, because the breakpoint is set to be up here. The breakpoint is set on here. We didn't quite get to it though. We actually got to the part above it. So we actually want to go ahead and figure out what we actually want to do. So here we have a 32. Now what that told me when I did my analysis basically is we need to provide a 32-bit long string of text. So again, like as me being a noob, I'm going to go ahead and just exit out of GDB, because I found that if I didn't, it would break things and wouldn't give me what I wanted. It would just glitch. I'm going to go ahead and exit out of here, Python, yeah. I'm going to go ahead and just basically do the classic buffer overflow technique of a bunch of A's. We'll go ahead and try this now. So the reason we're doing 32 is because we have 32 in this here. We'll go ahead and now go into here, go ahead and copy. We'll go ahead into, actually I'm gonna have to do something real quick. Break into main real quick. We'll go ahead and run it. We'll go ahead and just grab this because I need to basically prepend, go into here. It's not where I want to be. I want to have this here. Drop this here. Cool. I think it was 9BD. Cool. Grab this. Cool. Go ahead and just quit again. Quit. Yes. Go ahead and reboot it. Cool. Go ahead and just remove this out of the way. And Ghidra as well. Fine. Go to break, star, right click, paste, 9BD. Cool. Hit enter. Go to run. You put in our password. Now what we should see now is a breakpoint after here. Hit enter. Interesting, something happened. That is because I put in the wrong thing, I now realize. I realize it's supposed to be 9B something else, not 9BD. My apologies, it should be 9B9. Okay, that's where I messed up. Let's go ahead and restart this because I am clearly blind. Go ahead and just do this again. Go ahead to break, star, go into our mouse pad, change this to a 9. Again, binary analysis isn't really my strong suit. Very much learned this on the fly and it took me ages to do it. But that's okay. We all got to learn somewhere. Hit enter, go to run. It's going to ask us for a password. We'll go ahead and take this, copy, paste, hit enter. Now we hit the breakpoint. Okay, so now is the crucial step, right? What we want to go ahead and do now is you want to go ahead and actually look at the data. So if we go over to this exact line, so line 165, or this exact memory address, 9B9, we can see there's a comparison between this register and this register. Now, if we go ahead and look at, say, RAX or R15, we'll go ahead and basically get the input data of that, so what the actual memory is equal to. I'm going to go ahead and look at the R15 register. We'll go ahead and now type in, which is a little bit complicated. Again, not massive in my area, but from doing this, basically what it will give me is the contents of this register. Go ahead and hit enter, and then what we can go ahead and do is now pull out the data within the register. It's kind of messy, so I'm going to go ahead and just clean up a little bit. Go ahead and open up a new one. Go ahead actually and just save this as, we'll just save it as a hex out. Cool. Go over to here. I think I have I think I already have the string I used from before. Yeah. And what this will do, basically just remove all the hex crap, basically remove all the zeros and stuff and that kind of thing. Fine. Go ahead and now just open up a new one. Again, just to make it easier for me, I mean, I could actually just new line it, but it takes like 2 seconds to do it in here, so I'm just going to do it in VS Code. Cool. Copy. Sweet. Now we can go ahead and take this data forward. Okay, so how do we go from here? Well, we actually now have this string of data that was in memory. Now we need to go ahead and decrypt it. So in comes CyberChef. Now, there are obviously other ways to do this. I use CyberChef because it's just easy and it's clean and you kind of know where you're at. But we need a few parameters first before we can do anything. Let's go ahead and view CyberChef first before we make any assumptions. We'll go ahead over to AES, go to AES Decrypt, and it wants a key, an IV, and a mode. Okay, so we know the key kind of because it's up here, but unfortunately it's a little bit awkward to get to because, as I then realized, this is in little endian, so it actually doesn't work quite how you'd expect it to. It's going to go like AE, 8E. It's like backwards, basically. So AE, A3, E8, and it's just awkward. So rather than making this complicated, I'm going to go ahead and just pull them out directly. All you need to do really is just reverse these. I think there is a way you can pull it out, but I'm not that good at binary analysis, so I had to do this manually. I'm sure there'll be a way to reverse the little endianness of this and like pull it out. But obviously I'm still figuring this out very much. But yeah, I'll go ahead and just pull out now. And here we have it. I just basically copied this from my notes. We'll go ahead and take the key, go into AES Decrypt, paste this in here. Cool. And it accepts it, which is good. Go ahead into our mouse pad, which is up here somewhere. Go ahead and grab this, go to AES Decrypt. And then we go ahead and drop in our big lump of data from before. Drop it in here. Okay, so we got some crap back, basically. That is because we aren't using the right mode. Now, if we go into Ghidra, we can actually see that the AES aspect, wherever it is using CTR, right? And we even know that from our lookup here. It's using the CTR version of AES. So we'll go ahead over to AES Decrypt to modify this to CTR. And there we have the password, which is awesome. This took me way longer than it was supposed to, but those are the simple steps to get it, and we can progress. Go ahead and SSH back into our Karl user, go ahead into pass in his password, which I have stored in my notes. Annoyingly, didn't actually put these into the full write-up. Go ahead and pop this into here. Hit enter. Cool. Sudo -l. Drop the password in again. Hit enter. Go ahead and pull this out. Sudo. Hit enter. Done. Cool. Now we drop in our fancy new password. Rust for security at developer 2021. Pop that in there. Make it a bit bigger. Minimize CyberChef and all the Ghidra and stuff so you can see it all nicely. Hit enter. And now we need to go ahead and get an SSH public key. We'll go ahead and just, I'm going to go ahead and just cat mine. If I can type properly. SSH ID pub. Cool. Grab this. What this will now do is it'll basically just add in the public key to the box. We can now authenticate its root. And now we can go ahead and get SSH root at $box. Hit enter. And we are root. The box is rooted. Cat root, root.txt. Boom. Cool. Well, if this proved helpful to you, then leave a like, comment, subscribe. Thanks for watching, everyone. Again, binary analysis isn't really my area, so it took me way longer to solve this than I needed to, but yeah, hopefully you can see I was trying. But I will see you next one. Take care, everyone. Bye.